So in this video, we'll be looking at what we call commutative property, associative property, and the distributive property, or if you want to call them laws. So this is basically a concept that is used in mathematics that we can actually know if it makes sense or if we actually have two numbers or say three numbers, and if we should actually switch them up, or we should multiply them another way, or we should group them another way, if it actually makes sense, if the order in which we change these numbers, if it actually makes sense. So we're looking at the commutative property, the associative property, and the distributive property in that sense. So let's look at the commutative property and see what it really means. Well, the word commutative, commute, speaks of going about, moving from one place to the next place. So if you leave from home, you go to work and you come back. And so we'll be actually looking at the commutative laws by looking at numbers. So if I have A plus B, would it be the same thing? Let me put a question. Would it be the same thing if I should switch the order of the numbers? Would it be the same? Well, let's try. Let us use real numbers and to find out. Say A is equal to 2 and B is equal to 3. Now, if I should substitute these numbers into the variables, let us see what we have, what we get. So on the left hand side, we'll have 2 plus 3 equal to 3 plus 2. And so let's evaluate this. So if we have let's continue to work with our question mark until we actually can confirm that the order in which we add these numbers, it won't change anything. So say 2 plus 3 equals 5, and also it gives you 5. So we can remove this question mark. So the commutative property is saying that it doesn't matter which order you actually change, you actually add. Well, under this operation, addition, it doesn't matter the order in which, when you are adding two numbers, it doesn't matter if you add the 2 first, and when you put the 2 in front of the 3, or you put the 3 in front of the 2, and you add them, you will get the same answer. So this works when you're actually adding numbers. But let us see if this works on the multiplication. So this is by the same A times B, and say B times A. Well, if we should use about the same values for the A was what, 2? We say 2 times 3. Let's check. So 2A is 2, B is 3. So we'll say times, 3 times, how we say, equal to 3 times 2. And if you see the order of the numbers, are actually there's like they interchange on the left hand side versus to the right hand side. So they actually switch position. So it's like moving the 3, putting it over here. So they actually commute. They are commuting. So let's see. Okay, so let's see. 6, I would say equal 6, and it actually works. So when you're multiplying two numbers, it doesn't matter the order in which you multiply. So if you have two numbers and you say, what is 2 times 7? I say, oh, no. It should be 7 times 2. Well, it doesn't matter which way you want to multiply, because the commutative property says when you're adding or multiplying, the order in which you multiply numbers, it does not change anything. But what if you want to try, let's say, take away? Let's try. So if we have 2 minus 1 would that be equal to 1 minus 2? So actually, when you look at the left hand side versus the right hand side, we actually do the same interchanging. But let's see, if you have this, you give me 1, and if I owe $2 at the shop and I only have $1 in my pocket, wow, so this is not equal. It's not equal. So the commutative property, well, is not true on the subtraction. But let us try division. Let's say we have 4 divided by 2 is equal to 2 divided by 4. And as you look at this, you know that by intuition, by just looking at it, you could just simply just continue to say, well, we said 2 into that give us that, and this is give us a half, or actually 0.5. And so we realize that the commutative property does not work with subtraction and division. So that's it. So it works with addition and multiplication. So the order in which you switch the numbers, it doesn't matter. Let's look at the associative property, and that is the word associative. We actually think about associating or grouping the numbers. Association, we are grouping the numbers. So if I have, let's say, let's use some letters. If I have A plus B plus C, so if I should group these two, would it actually be equal if I should add, if I should actually use addition, and we say, I actually group them the other way, like saying that A plus B plus C. Would this would this even make any sense if we should actually, if you had 3 numbers and we were adding them? Would if we group them in addition like this, would it actually be the same? Let's try. Let us assign numbers to these variables. So let's say A is equal to 2, B is equal to 1, and C is equal to 3. So we can just substitute the values and see what happens. So if we are so let's see, 2 plus 1 group plus 3, 3, and that is left outside, is equal to, let's change this, let's say 2 outside plus what's inside the bracket, 1 plus 3. Now let us work out the left hand side and then the right hand side, and so what is what? I'll just put a question mark there. So we have 2 plus 3, 2 plus 1 gives us 3 plus 3, and we say 2 plus, what's that, 4. And if we say 3 plus 3 give us 6, equal to 2 plus 4 gives us 6. So it actually works. So the associative property works under addition. So it doesn't matter which one you want to group first and put in parentheses or in bracket. The associative property says it doesn't matter which 2 you group first and leave 1 outside with these 3 terms. Once you're adding, it doesn't make any difference. Let's use multiplication with the same associative property. So let's use, we could use by the same numbers. So we could say 2 plus, let's see, 1, oh, it's multiplication, times 1, and then we have multiply by 3, and then we say equal to, let's say, what's that? 2 times 1 times 3. And let's simply just evaluate this and see what we get for both sides. So we say 2 times 1 gives us 2 times 3, and we say 2 times 3. And if you look at it, we're actually having the idea of the commutative property. And if we actually have the commutative property, then we actually get the same thing. We get, is it 6 over 6. So we actually see it works with the associative property. So when you actually add and multiply numbers, by having 3 numbers grouping 2, leaving 1 outside, and grouping the first 2, leave the last one outside, grouping the first, leaving the first 1 outside and grouping the 2 last one at the back. It doesn't matter what you do in addition and subtraction, you will get the same answer if you should do that. So that is associative property. Well, let's see if it works with subtraction and division. So let's work with subtraction first. If I have 2 minus 1 minus, let's see, 3, we're just using the same numbers. And we say, what's that? We say 2 minus 1 minus 3. Let's see what happens when we do this. So we say, we subtract, so we get 1 minus 3 is equal to 2 minus 4. Right, 2 minus 4. And so we will have, let's see, so we have, let's see, we have, let's work on what is in the parentheses first, but in the bracket. So if we show based on the order of operation, then in the bracket you'll actually get -2. And so this is what you get, -2 is equal, well, let's put the percent sign. Do we have what? 4. So if we should look at it, we will not get the same answer. So subtraction is not associative. It's not, well, it doesn't work under the associative law. Let's look at division in the same way. So if we say 2 divided by 1, let's say divided by 1 divided by 3, let's see if this equals. So if we say 2 divided by 1 divided by 3, so actually using the operations throughout the whole process. So let us work this out. If we say 2 divided by 1, it gives us 2 in the bracket for here. 2, and you could just simply write this 2/3. And equal to, let's see, the question mark there, we are not sure it. So we say, so this would actually be, let's look at it, it'll be 2 divided by, let's say, 1/3. And when we have a fraction, that you could actually simplify this by just, keep, change, flip, that kind of idea. So we'll do, write this back, 2, 3 is equal to, let's say, keep the first fraction, which would be 1/2, and then we'll change the sign, and then we actually find the reciprocal of the last fraction. So we have 3/1, which finally would be, let's say, 2/3 equal to 6. And this is not true. So the associative property does not work with subtraction or division, because when you evaluate both sides, they are not the same. But it works with addition and multiplication. So let's look at what we call the distributive property. And distributive property is quite simple and straightforward than the other two. Very, very straightforward. So distributive property simply tells you, well, it actually what it does. There's a scalar value outside being distributing itself to each term in the bracket by multiplication, and that's simply it. So if I had, so I would say, let's say, if I have A, say B plus C. So this is a distributive property. This is saying that this A will be distributed by each term. So it looks like this. A times B gives us AB plus A times C gives us AC. And so this is how the distributive property looks like. So if we were to use the same numbers, so we say that what was A? I think A was 2, I'm not sure, but it doesn't matter. B was 1 and C was 3. It really doesn't matter what value you want to use. So let us see if this side, if the left hand side will be actually equal to the right hand side. Well, just by looking at it. So if we say 2 outside as a scalar value, B is 1 plus 3. Well, if we should follow the order of operation, we'll actually get, let's say we work what is in the bracket first. So 1 plus 3 will give us 4, and if we should say 2 times 4, that gives us 8. So this side will actually equal, well, if we should look at it like this, this will be, this side would actually be 8 because we're actually working what is in the parentheses or in the bracket. So after adding them, we will actually multiply the scalar value by what is inside of the bracket. But we could actually try this way and see if we get 8 just the same. We could just simply substitute the values in this way. We could say, okay, we could basically say let me see. We could actually basically say what's A is 2, B is 1, C is 3. So we'll say 2 times 1 plus 2 times 3. And so 2 times 1 gives us 2 plus, let's see, what's that? 6. And it's also this being 8. So that's basically it. So look at the commutative property, the distributive property, and the associative property. And we actually learned that based on the operation, the order in which we change the numbers, it might work and it might not work. So commutative works with addition, subtraction. No, addition and multiplication. Associative law works with the same. And for division and subtraction, they don't work. And so we look at distributive property in a very simple way. I was distributing the properties and so on. So there you go, the 3 laws: associative, distributive, commutative property. I hope this video will be of good use to you, and remember to like, share, and subscribe. See you next time.